here at the first day of the LNG Shipping and Terminals Conference in the Hilton Hotel in London. And we've had sessions on demand, and we've just had a panel discussion with quite a free-flowing question and answers going on there. And I'm here with Andy Brown, who's the LNG Business and Project Developer at Smit Lamnalco. And you were asked quite an interesting question, because you're doing marine services at LNG facilities. So somebody asked about having escort tugs and the marine services operating on LNG, and so what are the pluses and minuses of doing such a thing, in your opinion?
Well, the plus aspect is there's available fuel there. That's the first thing. You've got LNG, you're working LNG terminal, so you've got the ability to have the fuel. The minus, I suppose, is how do you get the fuel from the terminal onto the tug? Now, you could do that through the existing manifold, but a lot of the LNG terminal guys, that manifold is purposely built for an LNG carrier, and to modify it may not be a suitable option. So the other option is then to have a separate manifold system, which then adds cost to your operation. And of course, that manifold, that additional system, you've got the decanter off the LNG terminal to be able to provide the capacity of fuel that you need for those tugs to run on LNG. Now, that's also a possibility, but then you've got to look at the cost versus reward. Can you build that decanter LNG fueling facility and make it commercially acceptable? You know, and will you get a payback on the fuel? Now, again, that's just basically working out the engineering and then putting that ability to work. But the challenge you've got is it's the operational profile of the tug. Now, if I'm running from A to B, I'm going to be a very high profile, very high load on my engine, and I'm going to burn off more gas. Now, as a tug operator in an LNG terminal, you spend a lot of time idling. And the problem is that engines don't like to idle on gas. They like to run at full profile because they can burn off. They're more efficient at burning off the LNG and burning that fuel. But when I'm idling, I'm not burning that fuel. So then I get a thing called methane slip. So the slip is coming through the exhaust because I'm not burning off the molecules, because I don't have enough energy to produce. So that's the biggest challenge, is methane slip is the biggest challenge for us because we idle. So it's not the fact that we can't do it, it's the fact that we don't have the operational profile, which may not be suitable for LNG. Now, the engine manufacturers, they all are aware of this, and they're working towards ways of actually developing anti-slip. Let's call it anti-slip for an easy description. So how can I stop that slip? So that's up to the engine manufacturers to come to us and say, we've developed an engine that can run on gas, that when it's idle, we won't get any methane slip, and when it's at high profile, we won't get any methane slip. I don't think we're there yet, but some of the engine manufacturers are working towards that. But then again, it's about reward. If you look at the number of LNG terminals around the world and the number of tugs that be able to operate on LNG, if I go away and do all this investment, will I get that return on investment? And that's the big challenge. It's all about that return on investment, to actually go away and do that research and then come up with a suitable system or suitable engine system that can do that. So they're the big challenges for us. The other challenge, of course, is we've got to get the competency on that tug, and we've got to have certificates of proficiency and guys that are qualified to be able to do that transfer of LNG and be able to manage that whole fuel process, which is completely different from what we do today. So we would then have to have a much higher level of competency and a much higher level of training with, you know, so to do that, again, there's also then adding cost into the operation. And of course, you've then got to put the fuel system on board. And of course, that requires a fuel tank. And that fuel tank, you then have to design the tug in conjunction with the IGF code, the International Gas Fueling Code, and of course then the tug's going to get bigger and it's going to have more cost. So you've got a capital cost to address, and you've also got an operational cost to address. And then when you look at the lifespan, say 20 years, will I get my return on that investment if I switch over to LNG? In some cases you might, majority of the cases you may not. So the LNG terminals are a little bit reluctant. If I'm selling 12 million tons of LNG and my marine service provider only needs 300 tons a year, or 600 tons a year, or whatever the capacity is, then the economics don't match. So that's why we haven't seen this mass rush into, you know, refueling or fueling the tugs with LNG. However, what we do see today, there's a couple of FSRUs now that are in the world that do have the capacity to provide LNG bunkers.
Okay.
So we see that now in, for example, in Hong Kong, the support vessels do actually, they're dual fuel, so they can run on conventional fuel or they can run on LNG. So, and they can actually fuel from the FSRU, which is great. There's also in Dubai, the FSRU in the Dubai also has the ability to fuel, to provide bunkers. But the economics would, if I was in that situation, what I would be doing is I'd be looking at going for the bunker vessels and saying, please come and, bunker from my facility. I can provide you LNG. If as an LNG producer, I would be looking at bunkering vessels because there's more capacity. Will we see more in the future of these FSRUs and floating facilities be able to provide fuel? Possibly, but it's all a question of economics. And then once you understand the economics, it's then understanding the operational capex and the operational costs as well. So the OPEX and CAPEX are going to be the ruling factor. And if that's agreeable, then you've got to look at the infrastructure that's going to support it. And that's the big challenge for the industry, is how would we get that infrastructure? That qualification for mariners, it's not widely available at the moment. You have to sort of develop it. So, and if you don't have that infrastructure, how do you go away and develop it?
And as we heard, there is the other side of the equation is if you're involved in developing the infrastructure, if you're involved in developing crew competency and maintaining, because it won't be a one-off, it'll be something that'll have to be developed. Now you've got a valuable crew. Now the port has got valuable knowledge that you have provided, and the second mover is the one that gains from all that. I mean, that's another possible scenario, don't you think?
Yeah, it is. I mean, once you've got that resource available in your company, then you've got a groundwork. If you want to do another terminal, you can actually use this terminal as a competency field. So, you can bring your guys in, train them, and we've done this, by the way. Something we've done when we worked on FLNGs. Because we operate on 2 FLNGs in the world. In fact, we've operated on 3 FLNGs in the world. So we'll take our masters and engineers, we'll put them in one field, get them experience, and then we'll move them over to the field, onto the new field, and so they get that experience. So once you've got it inbuilt, but it's that classic, I hate the cliche, I really do, but it's that classic chicken and egg, which is going to come first. So if you don't have the infrastructure, you're going to have to go and get it outside. But if you have the infrastructure already, then you've got a base ground, you've got somewhere where you can start training your guys, identifying the competency levels, and then building them up and then getting their proficiencies up and such. So because you've got that infrastructure to work with. If you don't have it, it is challenging. There's no doubt about it, it's challenging.